Everybody. So in this video, I want to talk about vectorization and specifically a word vectorization. And so I think that this tutorial that we're looking at here does a decent job of explaining what vectorization is, but I think we can go into more detail. So with I'm going to skip over number vectorization because it's my assumption. So vectorization is a mathematical concept, and then so my assumption is that you already understand that mathematical concept is inherently like numbers and math. So that's pretty self-explanatory. But how do we get from like numbers and math to representing words with numbers and math? And that's kind of where I started out with vectorization. And so the simplest way for me to wrap my head around this, like I come about this like not as a mathematician, more my educational background is more on like the philosophy side and liberal arts, and so the very first concept that strikes me with regards towards vectors, and the first concept that I related it to, was Platonic forms. And so if I envision word vectors as Platonic forms and in the same realm as Platonic forms, that makes 1,000,000% sense to me. And then so how I envision word vectors are that if you wanted to come up with the Platonic form of grandfather, for example, and you wanted to actually measure that Platonic form. So like the Platonic form of grandfather is a metaphysical concept. There's no way to measure what the Platonic form of grandfather is. Like, what's the perfect form of a grandfather? I don't know, but we can measure the elements that make up a grandfather. So, for example, we would know that a grandfather is a man and they're an adult, and that they were once a boy and once a child, but that they're not a boy or a child, but they are a man and an adult. And so we can know, like, so with that we can define some of the characteristics. Like, we can start to define what the Platonic form of a grandfather is. We're never going to be able to use this to come up with like the full equation, but if we went through this method and we pulled out enough of these elements, we could define like what, like 99.9% of the essence of what a grandfather is. And so word vectors, that's exactly what they try to do, is they try to capture the essence of a word. And so within that, there is inherently going to be a flawedness, like an amount of flaw within the vector that they create, because they're not creating the Platonic form of the vector, like of the word. They're creating like they're measuring different elements of the word. So when in this example, when we're talking about grandfather, these are the only elements that we have to discuss grandfather in this instance are man, adult, boy, child, etc. But we don't have any, like on this particular chart that we're looking at, there's no relationship between grandfather and grandmother. What does that mean? Like, like I would imagine that grandmother is somewhere in the essence of the full Platonic form of grandfather. So if we were to talk about grandfather holistically, we would also talk about grandmother. We would talk about son. Uh, Several different elements that are father, different elements that are not on this chart that would make up and that we would need to define what grandfather is. But that doesn't mean that we can't define specific instances of grandfather. And then so that's what word vectorization is the measurement of a specific instance of a specific word, if that makes sense. And then so when we come to like looking at this in code, so kind of the first thing that I do is I try to understand the philosophical concept of it. Okay, so I understand word vectorization a little bit more now philosophically. It's only measuring certain aspects, and we define the certain aspects of whatever it is. So in this instance, if we're measuring apple, we could measure different elements of the apple. So the main code that we're looking at here is designed to measure the sentimentality of words related to the word apple. And then so in this instance, it's doing a sentiment analysis on the sentence, I love apples, and then finding out that that's a very positive sentence, and that there's positivity overall in relation to that statement, and that none of those words are negative words. But I could do other things. For example, if I wanted to understand the color of an apple, I could view it, I would utilize a different vector. I'd be looking at the color of the apple. And then if I wanted to, even within that, there's different ways to measure that. So one way that I could measure the color of an apple would be the RGB method. And then if I did that, then this would be the color of an apple. But if I utilized a different method, such as the HSV method, then this would be the color of an apple, 0, 100, 100, as opposed to 255, 0, 0. So and these numbers are not arbitrary either. That's the other thing that is important within this, right? Like, so the RGB color scale is like it's a scale that has been around. Like, I didn't invent the RGB color scale or the HSV color scale, and so none of these things are arbitrary, and none of these numbers that are being assigned are arbitrary. But so what the goal is then that the machine assigns these numbers and then it utilizes these numbers to be able to determine certain things about and patterns within the word itself. So the idea being that if we take several vectors of apple, and so if we took the sentiment of apple, the color of apple, the type of fruit an apple is, like any other elements that we defined apple, and then we utilized like the number that is associated with apple, the number that ends up being associated with apple, depending on how we want to measure it, would be similar to the number that is used to represent orange, which would be similar to the number that is used to represent banana, which would be further away from the number that is used to represent broccoli. And then so orange and banana would be very close to apple, and then broccoli would be closer to apple than paper plate, but would be further away from apple than orange or banana. I hope that makes sense. And so it's a kind of an interesting concept to wrap your head around in that sense. And so the important thing to remember with that and in that aspect is it's the AI that is assigning the numbers in these instances for the most part. And then like these numbers aren't random. Like it's not just assigning random numbers to things. If whatever number it gets assigned to it, if you give it to another AI model, it can read that number and understand that number. It's like a language for whatever the pattern is behind whatever you're trying to measure, in this instance, apple. And then so when people say that LLM models and AI models can't understand like the actual like meaning behind words, or like they're actually just utilizing math and recognizing patterns, things like that, everyone's talking about these lines. Like this is how essentially an AI model visualizes the world. And then so for me, like honestly, like I've had kind of in-depth discussions with AI models about this, trying to understand this. And then so kind of the very first thing that I picked up on honestly within this is that if you talk to an AI model about vectors and vectorization, they tend to describe vectorization more in the sense of their environment. And that makes sense to me. So the way that I've been describing vectorization and my base opinion of vectorization, like my first thought on vectorization is that it's related to language. It's like there's a language that I can break down apple to, and then if I define apple based off of its sentiment, then that is a certain number which is related to language to me. And if there's a certain color related to apple, that's just related to language to me. But to an LLM model and to an AI, those same concepts are related to environment to them, just more closely offhand. And like that makes sense to me intuitively. And then so the way that AI models like view these vectors is inherently different than the way that humans view these vectors on that level. And I don't know exactly what that means, but I think it's interesting to, and it's important to note and to highlight within this video. And the last thing that I want to highlight within this video is that, like, so vectors are important. Like vectors are the universal language essentially that machine models learn to or use to like express, like it's their language essentially, is kind of how I look at it, right? if they're looking at an apple, like they're not looking at, or the word apple, they're not looking at the word apple, they're looking at the vectorization and trying to pull out like different characteristics of that word apple within the context that it's being used in, different, like a whole bunch of, a slew of different vectors, right? And they combine those vectors and then they do different things with them. And so within that, you don't just have to expand that to words. So like it's vectors are a mathematical concept, and then it was discovered, hey, we can apply vectors to words, and then it's like, whoa, like, you know, that's pretty cool. But so once you make that realization, like, hey, you can apply this to words, like it's not just a pure mathematical concept, you can utilize vectors to describe anything. Like it doesn't have, like, it's the form of anything, and to, like, you'll never get the Platonic form again, because the Platonic form is inherently different than the vectorized form, because the vectorized form is essentially trying to measure up to the Platonic form, but it will never be an accurate representation or an accurate 100% accurate measurement. So you'll never be able to get to the Platonic form via vectorization. If that makes sense. But so overall, you can do that, and that incomplete measurement process to anything, like any concept that you could possibly imagine. If you just pick out the individual components of it, you could vectorize it and then search for patterns within that. And that's essentially what AI does, and like how it thinks, and how it utilizes language overall. And so I'll leave this here on vectors. I'll make more videos that dive deeper into vectors. I've personally watched through all of the YouTube videos on vectors right now, and they're kind of older and kind of lacking, in my opinion. So hopefully this does something to that general lexicon as far as the vector discussion, and puts a little bit more quality videos out there. I understand this is a hard concept to understand overall. I don't pretend to be like the vector expert. Like, I'm not the planetary expert on vectors. This is just my understanding of them, and then from a philosophical perspective, it makes a lot of sense, intuitive sense to me. I just click with vectors and Platonic forms. So hopefully my explanation and my correlation there makes sense to you, because that's the way that it clicks from my brain. So thank you very much, and thanks for watching.